Factoring review with Algebra 2. So this is going to be a quick overview of factoring because we have been factoring throughout this year, but if you need a more in-depth video to watch that goes slower, go back to Unit 2 because that's where we first learned how to factor, and you can watch videos on each type of factoring that we end up doing. So first we have 3 overall steps that we look for. The first one is looking for a GCF, which is your greatest common factor. And there are 2 parts to this. So the first part, if you have a GCF, write it outside the parentheses, and then you can move to step 2. If you don't have a GCF, then you can move straight to step 2. Step 2 is factoring the way we call playing the game. And in order to play the game, you need 3 terms, and you want x squared to be positive. So those are the 2 big things you want to look for when playing the game. Then, if you can't play the game, you have to look for our special cases, which is our difference of squares, meaning we are subtracting perfect squares. So like x squared minus 4. And then your sum and difference of cubes. And that's when you have an x cubed plus another perfect cube. There is one more type of factoring, and that's when you have 4 terms. And that is called grouping. And again, if you forget about grouping, go back to Unit 2 and watch the video on it. It doesn't pop up too much with these. Most of the stuff we're going to use in Unit 6 is by playing the game. So I'm going to go down to some examples. So I have example 1, x squared minus 5x minus 6. So I know x squared is positive, which is good. First I'm going to look for a GCF. Here there is no GCF that is bigger than 1. They don't all have x, and I can't divide them all by a number. So I'm going to move to step 2, which is playing the game. So you take the number that's in front of x squared, which in this case is a 1, and you're going to multiply it to the last number, which is negative 6. So I need to find 2 numbers that multiply to negative 6, but add to my middle term of negative 5. And again, we can use our calculator. If we are unsure, we can go y equals, type in negative 6 divided by x, second graph, and this will give me all the factors, and I can move up into the negatives. From here, I see that I can go with negative 6 and positive 1. Now let me double check. Negative 6 times 1 does give me negative 6. Negative 6 plus 1 does give me negative 5. With this, I can use my trick, because the number in front of x squared is 1. So these end up becoming my 2 factors. I'll say x minus 6 and then x plus 1. And that's my factors. Remember, factors stay in parentheses. Now looking at number 2, let's see, first here I have a GCF. I can divide them both by 3, and I can take 3 x's out. So my GCF goes outside of parentheses. 3x to the third, outside of parentheses. 3 divided by 3 is 1. I don't need to write it. X to the 5th divided by x to the 3rd. We just learned we subtract our exponents. 5 minus 3 gives me 2. 9 divided by 3, I'm left with positive 3. X to the 3rd divided by x to the 3rd, nothing left. Close my parentheses. Now here I do have to look inside. Can I continue to factor this? I can say no right off the bat because I realize this is a plus sign. My special case is when I'm subtracting, and these are not perfect squares. So this is actually my final answer. Let's look at the third one. So first, I always want to look for a GCF. So in this case, I can divide all of them by 5. And this is why a GCF is so important. I write it on the outside. 5 divided by 5 leaves me with just x squared. And since there's no longer a number in front of x squared, that means I'll end up being able to use my trick here. So x squared, and then plus 35 divided by 5 is 7, and it has the x. Then 50 divided by 5 is 10. Again, I have to then continue. I look inside the parentheses, and I can continue to factor here. So I have what is being multiplied to 10 and adding to 7. You can go to your calculator and find numbers there, but I know they are 5 and 2. 5 times 2 gives me 10, 5 plus 2 gives me 7. So then, because I had a GCF, I took out that number in front of the x squared. These two numbers over here that I found go immediately to my factors. So x plus 5 and x plus 2. But then we have to bring down our GCF from the beginning. That's my answer. And lastly, we have a special case. Here I know it's a difference of squares because I am subtracting. There's two terms and they are both perfect squares. X squared is like x times x. 64 is 8 times 8. This is when it is helpful to know your perfect squares. If you aren't sure, you can always take the square root of 64 in your calculator. So now when I go to factor this, I get x plus 8 and x minus 8. Those are my factors. Again, I know this was a quick overview. Go back to Unit 2 and watch those videos if you need additional help.